Hello, in this video we'll shortly talk about lattices. I'll give the definition and I'll give a few examples, and then in later videos we will go in more detail into it. So let me tell you what a lattice is. First note, there's also a notion of lattice in order theory, but we will talk not about that, but about subgroups of Rn. So a lattice is a discrete subgroup of Rn for some n. Okay, let me give you some examples. So the first example, well, let's look maybe first at the case for n equal to 1. So for instance, we have the real line, we have 0 here, and then and just to make it so Rn, and just to make the group operation clear, so we consider it with addition, and then we can basically take here any point, let's say a, then we can take 2a, 3a, minus a, and so on. So we can take c times a for a real number. So that would be an example of a lattice in R. In fact, these are all lattices, so we'll see later that we can write so in a later video I'll just state it. So every lattice, let's call it lambda in Rn, is of the form CB1 plus and so on, CBK with k at most n, and the BI linearly independent. And so that's lambda. And so these BIs we will call this the basis of the lattice, but we'll prove that later. And now let's look maybe at the case for n equals to 2. So we can, for instance, then just take C2, or we can also take different things, but let's start with C2. So then it looks like this. So that's, and of course it goes on like this. And so if we identify R2 with the complex numbers, then C2 corresponds to C adjoint I, and then we get the Gaussian integers, which are actually a subring of the complex numbers, and in fact they are a so-called ring of integers and even an Euclidean domain. And yeah, in general, lattices appear quite naturally in algebraic number theory, but they also appear in a lot of other places. So you might have heard of the E8 lattice, for instance. Maybe we'll also see a little bit about that. And lattices, and maybe we'll also see a little bit more about lattices in C. So there's a notion of similarity or homothety, which relates to modular forms and elliptic curves. But probably we're not gonna go that deep into it, but maybe we'll see a little bit about that. And so, or just to give you further examples, so it doesn't have to be regular like this, we could also take as our basis vectors, let's say this is 0, and then we can take these two linearly independent vectors as our basis vectors, and then it goes on, or maybe that was too short, it goes on like this, and then we maybe like this, and then, so yeah, I guess you get an idea of how it looks like. Well, it should look a little bit more even spaced and regular because I didn't draw it that well, but I hope you get the idea. Okay, and then of course this generalizes to higher dimensions, and yeah, that's already all I wanted to say for this video. So in the next video we'll prove this theorem, and then we might see a little bit more about lattices in C, and maybe also the E8 lattice, and maybe also relations to algebraic number theory, but I'm not yet sure about that. Okay, thanks for watching, have a good day, bye.